The laws of thermodynamics, often referred to as the first, second, and third laws, provide fundamental principles governing energy and its transformations within a system. Here's an explanation of each law. 1. The first law of thermodynamics, also known as the law of energy conservation, states that energy cannot be created or destroyed in an isolated system. It can only be transferred or transformed from one form to another. This law establishes the principle of energy conservation, indicating that the total energy of a closed system remains constant over time. 2. The second law of thermodynamics introduces the concept of entropy, which is a measure of the disorder or randomness in a system. It states that the entropy of an isolated system always increases or remains constant in any natural process. In other words, systems tend to naturally move towards a state of higher entropy, where energy becomes more evenly distributed. 3. The third law of thermodynamics focuses on the behavior of systems as they approach absolute zero temperature. It states that it is impossible to reach a temperature of absolute zero through any finite number of processes. Additionally, it provides a reference point for entropy by stating that the entropy of a pure, perfectly crystalline substance approaches zero as the temperature approaches absolute zero. These laws collectively form the foundation of thermodynamics and help us understand the behavior of energy and its transformations in various systems, ranging from microscopic particles to macroscopic environments. There is a zeroth law of thermodynamics in thermodynamics. Here is an explanation of it in English. The zeroth law of thermodynamics is a principle concerning temperature and thermal equilibrium. It states that if two objects, A and B, are separately in thermal equilibrium with a third object, C, then objects A and C are also in thermal equilibrium with each other. In simpler terms, if two objects have the same temperature as a third object, they will have the same temperature as each other. The zeroth law provides a basis for quantifying temperature and serves as a reference point for temperature measurement using thermodynamic scales. It plays a fundamental role in determining the direction and extent of heat flow between objects in contact. Therefore, in thermodynamics, there are four main laws. The zeroth law, followed by the first, second, and third laws.